I can't do an insert on department 10. I get an error saying, yep, department 10. Ah, but I still got the trigger on there. We have a table where some of the records should be updatable, but others must be read-only. Can you advise on how we can do this? The table is not partitioned. And so rather than talk about methods, I thought we'd just go in and do some demos and explore some methods and the pros and cons of various methods. And we'll do our first demo and we'll see what we can do in terms of controlling which rows in the table can be updated and which ones cannot be. It's important that they said the table is not partitioned. And I thought just briefly show you the declarative way of doing read-only tables if the table is partitioned. And so for this customer, if they had a mechanism where they could actually choose to partition their table into the rows that should be readable and shouldn't be updatable, then that would be an obvious way forward. But let's assume they can't. But just to show you that you have this declarative read-only facility if the table's partitioned, here's a table called T. It's partitioned by list on department number. I've got two partitions, P10 for department 10, P20 for department 20, and it's just all the rows from scott.emp for those two departments. This is the simple demo. If you want to make a particular partition read-only, I think since maybe 12.2 or 18C, you can now do it declaratively. You can make a table read-only, or you can make a partition of a table read-only. You simply do alter table modify partition, P10 is read-only. Just to prove it, I can still do DML on department 20, but I cannot do DML on department 10. So if it's partitioned, this problem is trivially solved. The question is, what do we do if it's not partitioned? Let's explore some options. So I'll drop my table. Let's recreate it as a copy of scott.emp, and it's obviously not partitioned anymore. There's my data. I've got departments 20, 30, and 10, and we're going to impose a rule where some departments are updatable and some are not. This is one option you could perhaps consider. Every time you change a row in the Oracle table, we fire the check constraints. And therefore, if we're firing the check constraints, perhaps I could put on a check constraint that would always be false given a certain condition. So in this case, if the department number is 10, then this check constraint will be 1 equals 0, which will always be false. Therefore, the check constraint would be always violated, and therefore the update would be blocked. So let's explore that. Now, the first thing you'll discover, obviously, is you can't put that constraint on because it goes to try read the existing data. It finds a department number of 10. It says, oh, does 1 equal 0? No, I can't even add the constraint. But that's okay. We're looking at all future updates. So I would simply do alter table add constraint check with no validate, which means from this point onwards, if you do an update where department number equals 10, I'm going to fall into this area here. 1 does not equal 0, never will, and therefore the constraint will be violated and you won't be able to do any updates. Let's give it a go. I update for department number equals 20. That's okay. That's not one of my problem departments, and that's fine. Let's now do for department number 10, and it'll hit that constraint and get an error. And as you can see, it doesn't. So what's going on here? Well, the database is, in this case, too smart for its own good. It sees your update and says, you're not touching or modifying the department number. You're referencing it in the where clause, but you're not making any modification to the department number. Therefore, why would I bother checking that constraint? I don't need to check that constraint. That's just an unnecessary CPU overhead. I can bypass it because you're not touching the department number. That's unfortunate for us in this case because we wanted that constraint to fire in all cases. And we can see that if we actually add the department number in to the update, even though we're just setting it to itself, the database says, you're referencing department number. I need to go actually apply that check constraint, and therefore my check constraint is violated. Already we've seen there's a little bit of a hole in our existing check constraint because we'd have to then insist that we're always referencing the department number, which is unlikely. Let me drop that constraint. Maybe we can hack our constraint to make sure that it's always going to fire. And so I could do something like this. Now, we could do something a little bit more intelligent, but I've just thrown in some random values. Really, all I'm doing is making sure that every single column in the table is referenced. And therefore, whatever I do a set to, I'm always going to have to fire this constraint, even though effectively all these things will never ever be true, which is what I want. I want the constraint to fail when department number equals 10. So I run that through, and now if I try to reference salary or any other column in the table, even if I try to set something to null, that constraint is violated. Now, if the only issue we're worried about here is inserts and updates, then we're good, we're done. This is one way of doing it. But of course, check constraints don't fire when you do a delete because you're simply removing a row. This particular question, when it came in, didn't specify whether it was insert update and delete or just insert update, but a check constraint is a potential mechanism of looking at this. And I stress potential because we're going to look at some others as well. But as it currently stands, this check constraint option fails for handling deletes. Let's drop the constraint now and consider another method, which is probably the one that most people are thinking of, which is let's just whack a trigger on, which is every time someone tries to do an insert or an update or delete at row level, if the department number equals 10 as an insert or the department number equals 10 as an update or a delete, then bang, we'll raise an error. So we'll never get past that trigger. And so we can test it. Update for department number equals 20, that's fine, as we want. Update for department number equals 10, I didn't have to nominate the department number or any other columns. Yep, my trigger fires, we're done, and we get an appropriate error. Similarly, if I tried delete, same thing. Now the trigger has exceeded the functionality that we had with the check constraint. So trigger looks like the way to go. But if I do a SQL loader direct path load, then the database says, let's just ignore the triggers. So there's a potential flaw in that option as well. Using a trigger, you'd probably argue it's better than the constraint option when it comes to deletes. We don't know if this person was worried about deletes, but there is that possibility that someone could bypass this with a direct load insert. Maybe that's an issue, maybe it's not. But if it's not, then the trigger looks like a good option. Are there any other ways we could do it? One way we could look at doing it is using the virtual private database in order to control which rows are updatable. It used to be the case when this was first introduced way back in 8.1, it was simply a tool to secure the querying or the access of data. But since about, I think, 10.2, we changed it such that it could handle all DML. Let's look at this. Now, I have to change this demo slightly because I was running this as myself before, and I'm a DBA, and DBA privileges bypass fine grained access control. So let's do it as Scott. So my table called T, I'll grant access to it to Scott. I'll create a little package because the way row level security works is you have a package to control the setting of the predicate. The reason you do that is because then no one can see inside the package body to see what security rules you're applying to make the predicate. So I've got a very simple here function called T policy function. It always takes owner and object name. And all I'm doing is returning department number not equals 10. In effect, that is a predicate that will be applied to every single DML that gets applied. The way we apply that rule is we define a policy. So on my table called T, owned by me, I call that routine for insert, update, and delete. Okay, and it says do it on an update check. It's true, enable it, which now means every time I do insert, update, or delete, I invisibly add that predicate in. So what happens now if I connect to Scott, which has this predicate applied to it? I can do an insert on department 20. That's fine because I wasn't caring about department 20. I can't do an insert on department 10. So I do a select from for T where M7369. That's department 20, so that employee should be fine. I can update for employee 7369. That's fine, that worked fine. What about employee 7934? Their department number 10, our department that we're trying to control. If I do an update, and here's the difference thing with a row level security policy, I don't get an error, it just wouldn't let me update it. It simply said no rows were updated. Maybe that's the functionality you want, maybe it's not. You have that choice, but it is a subtle difference from the trigger which actually raises an error. This one simply says, yep, I'm simply going to block that. And if I try delete, I get an error as well. So to sum up those, the trigger is often considered probably the most simple of those options and perhaps the most transparent because the error comes up, it says, yes, a trigger has failed, and it says, here's your error message, you get to control the error message. And so it's probably the easiest way and most visible way. The check constraint, I think, is an interesting way, but it looks a bit cryptic in the definition. And you probably have to have some strong documentation to say why you've got this bizarre looking check constraint. I like the concept because what happens there is the trigger doesn't have to fire. So in theory, it should be slightly more efficient. One thing I haven't checked is whether adding a when clause to the trigger would actually make it even better. Every time you have a trigger on a DML, there's a slight overhead to doing it. That might be an issue for you, it might not be. The most important thing is in all these methods, make sure you try test it to destruction. For the trigger example, you've got to make sure that you're never doing SQL loaded direct load. For the check constraint, you've got to make sure that if someone adds a column, then your check gets updated. There's various things you have to be aware of. Do you always need an error? In that case, the row level security option is probably not the solution for you. Making sure you explore all the options and the consequences of that is important if you're coming to protect data, because one would imagine if you want data to be read-only, there's a very good reason for it. It's super important that it cannot be touched.